And you'll notice here where it's shrunk down that the heat-activated sealant has oozed out of the end. That's a good sign that you've installed it correctly.
See, what you can't really see is that Dennis is heating this up all the way so he doesn't have any flat spots or ridges. And you can tell, you can see it with your eye and you can feel it with your hand, though I would recommend don't touch the splice right now. So that's it, Dennis,
That's it. That's the 15 kV inline splice.
I'm standing in the middle of the AC test cage at our North Carolina facility. This is where we subject the cable accessories to some of the electrical tests. To my left is an 800 kV impulse generator. This mimics the effect of lightning or switching surges on cable accessories through a bunch of capacitors that fire at a certain sequence. It's all done electronically. Don't worry, it's all quite safe because it's grounded, as you can see with this grounding stick here. Behind me, in this blue cube, is a 250 kV AC transformer. We use this for AC voltage withstand as well as partial discharge measurement. It has some very strange looking corona rings up on the top. That's to eliminate any noise. And as you can see, it's safely grounded here. But what we're going to use this piece of equipment for today is to answer a couple of questions that we get all the time on cables. And that is, why do you have to use a cable termination? If you strip a high voltage cable and take the semicon back, you get a condition that looks like this, a semicon back here and insulation right here. Well, I'd like to show you what happens if you don't put a cable termination on this and energize it at any substantial voltage above 5,000 volts. What we've done here is made a cable. It doesn't look like a cable yet, but let me explain the parts. This is a tube like this, just a piece of steel conduit, and we have shrunk some insulating tubing on this piece of steel conduit, a couple layers, and then right here we put a piece of conductive tubing. This is a piece of the conductive tubing that we've shrunk on here. So that's what we have, a conduit underneath, some insulating tubing, and a semiconductive tubing shrunk on top of that, and this is grounded through this mesh right here. So now, for all intents and purposes, this looks like a cable. The conductor is underneath, you can't see it, but that's what we have right here. This is the same thing as the insulation, and this is the same as the semicon cutback. What we're going to do is energize the conductor, or the conduit in this case, and we're going to see what happens right here at the semicon cutback to show you what you can see as discharge. It's electrical discharge, and it will start forming right here as a very subtle blue haze, and eventually we'll have quite a spectacular show here. So let's see what we can do with it. We're going to take off the grounds. I'm going to get out of the cage so it's safe, and then we're going to energize this and see what we can see. Thanks. Let me explain a little bit about what was happening during that display. You started seeing some corona right here. This is the conductive tubing, and we started seeing the air break down right here. Air breaks down at about 21.6 kV per centimeter, and you started seeing air become a conductor because the voltage got so high along the surface right here that we exceeded 21.6 kV per centimeter, and all of a sudden air became a conductor. When that happened, we had a blue glow around here, and eventually we started getting some sparks. Now, it's high voltage all the way to the end, but you only saw that activity right here, and that's because there isn't any voltage drop out here. It's all the same high voltage. But when you get right here, you got to go from high voltage to ground in a very short distance, and that's what electrical stress is. The volts divided by the distance, and if that exceeds 21.6 kV per centimeter, air becomes a conductor. Another good example of that is lightning, and that's really not a very nice situation. Anybody that's ever encountered lightning knows that that's bad, very bad thing to have. So what we're going to do right now is show you the effect of putting a termination on the end of this artificial cable. This is a stress patch, the same patch that we use in the cold applied termination, the TFT. It's a zinc oxide stress relief material. What I'm going to do right now is put that on the end of this phony cable, semicon cutback, and wrap it around like we would as though it were a real cable. And now I'm going to take this, which is the holdout. I'm going to install it on the end of the cable and make a termination on the end of our artificial cable. Okay, what we've just done is installed the termination on the cable, the phony cable, and now we're going to run the voltage up and see if this makes any difference. Today Dennis is going to show us a heat shrink termination, Raychem HVT, and that's been on the market about 35 years, hasn't it, Dennis, since the 60s?
Something like that, yeah. Late 60s,
so
mid-60s.
Dennis is going to walk you through the installation of this thing, but he's not going to show you the cable prep because he's already done that, and he's done an expert job here. So, Dennis, take it away.
So the first step in this installation is to fill in the semicon cutback, because there's a little step there, and what we will do, we'll install this black tube, which is a stress control tube, and we'll shrink it down there. If you don't fill in the step, there would be air entrapped at the step, and when they energize the circuit, that air will ionize and discharge, and probably eventually you would get a failure at that area, because this is a high stress area at the end of the semicon cutback. So we fill it in with this yellow mastic we call stress relief material, which is a stress controlling material. And it goes 1/4 of an inch onto the cable insulation and 1/4 of an inch onto the semicon. You don't need to put the full strip usually. Maybe you do on a larger cable, but that's all you need, just enough to fill in the step and get a nice taper down from the semicon down to the insulation.
Dennis, and some other kits, don't other manufacturers use like a grease or something?
Yeah, some manufacturers I've heard and seen, they fill in that step with a silicone grease, but
this is a little bit more robust and it stays there.
Yes, yeah.
Okay, Dennis, you just put the stress control tubing on there. What happens if you don't put a stress control tube there and didn't do anything at the semicon cutback?
Well, I have an example here where this is a 25 kV termination cable, and you can see the hole there. This is at the semicon cutback, or where it was sent in to me for analysis. They wanted to know why it failed, and I saw the hole, and it looks just like somebody shot it with a 22.
So if you don't put any stress control, you'll have a failure at that point.
Similar, yeah. Back to the installation now. This is the first tube to be shrunk. Normally a termination is upright, so we always start shrinking at this end of the tube and work our way along it so that no air gets trapped in there under the tube. And you have to make sure that you get around the full circumference of the tube to make sure that you get a symmetric recovery of the tube, and then just give it a little bit of flame brushing at the end, and you can see that it's nicely shrunk. There's no flat spots or cold spots anywhere, and that's a good installation. Next, we're going to install a moisture seal on the jacket, and to ensure that you get a good moisture seal, we like to make sure that the jacket doesn't have any grease or oil on it, so use this solvent ready to accept a nice moisture seal. You just dry off with the drying wipe, and then to further ensure that you get a good moisture seal, we just take the shine off the jacket with this abrasive strip. So you take this mastic red sealant, put 2 layers directly onto the cable jacket. Then you lay the wires back into the mastic. Make sure you don't cross them. If you cross them, that will give a path for some moisture to enter the termination. And then we put 2 layers on top. So what you have is a nice moisture block there. You made a sandwich of the sealant and the wires. Want to stay in place. Continue the sealant onto the insulation. So the next step is to install the non-tracking tube.
And what do you mean by non-tracking? What's the is there something special in that?
Yeah, because you know when this termination's installed and you get in humid conditions or high pollution areas or it's raining, the electricity wants to come from the cable lug down to ground, and the way it would do that is on the outer surface of this tube,
which could cause a track.
Yeah, it would cause electrical tracking and erosion, and you would quickly lose it. This tube is formulated so that it prevents that tracking. That's basically what we mean by non-tracking tube. We shrink it down in the same way that I did the stress control tube.
Dennis, that looks like it's too long. Is that a problem?
No, we trim it at the end. We make it a little longer than necessary.
So it's important to start that at the mastic, is that right?
Yep.
Okay. Remember, heat shrink tubings not only shrink this way or radially, they shrink this way, which is called longitudinal. And if you don't put it at a dimension that we call in the installation instructions, then you're not really sure where that shrinkage will happen. But since we have engineered these kits, we know that it could shrink lengthwise, and we take that into consideration in the design. So if it does shrink a little bit, it's not going to matter. And in this case, you can see there's quite a bit more at the end. And I assume you're going to cut that off?
Yeah.
Make
sure this is not properly shrunk by giving it a flame brushing like you saw me do there. And then when that's cooled off, or even now, put a glove on, I can trim this tubing to the correct length. You can feel the lug underneath. Now that's an indoor termination, and to convert it to an outdoor termination we install what we call the rain sheds. There's a dimension given in the installation instruction from the bottom of the tube. Now these sheds, the only part that shrinks is the collar here, so you don't need to heat the outer part, just this collar. And there's a technique I use to do it. I shrink it sufficiently so that the collar just makes contact with this tubing, and it usually goes crooked, and then just when it makes contact you back the flame off and straighten it up, and then finish it off, as I will show you.
And you use a slightly softer torch too.
So you just straighten it up, make it nice and perpendicular to the termination. It's just for aesthetics, that's all, just makes it look nicer.
So you're just applying heat to this center
to the collar, and give it a little bit underneath.
Okay.
Like that. And this 15 kV, it has 2 rain sheds.
And there's a dimension in the instructions on where they go?
Dimension is given.
And again, you're getting it all the way around, right? So you heat it up all the way around.
If the, usually terminations are upright, and you might need to hold these with a little pair of pliers or something just to hold them in position until you get the collar shrunk onto the to the tubing.
And let that cool off, and it's ready to energize?
Yeah, it's ready to energize.
Okay. Well, thanks a lot, Dennis. We appreciate it.
My pleasure.
Okay.
Anytime.